Hey guys, it's Mrs. Millette. We are talking about Chapter 7, Part 3 today, or Lesson 3. We just finished yesterday talking about the different types of muscle movements with rotation and flexion and extension. The first day we, of course, talked about the different types of muscle and things like that. But today we're going to continue our discussion with the 4 objectives that we have today. Sorry, I need to pull these up real quick. They are to describe sarcomeres, including actin and myosin. You need to describe how much slower smooth muscle contracts than skeletal muscle, and why it takes smooth muscle more time to repair after it's damaged. You need to know the difference between vasodilation and vasoconstriction, and you need to know how muscles play a role in both the digestive and the respiratory systems. So don't forget to be studying, as I'm finding my slide here, the different muscles of the body. You will need to be able to label them on the test. All right, so here we go. Muscles, like many things in our body, are surrounded by connective tissue, and that connective tissue is called the epimysium. And inside the muscle, inside this wrapping, so to speak, are these little bundles, and they get surrounded by something called the perimysium. And then you have another part that's called the endomysium. Now, I could make you know all that, but really that's not important at this stage in knowledge. What I really need you to know is that the functional unit of a muscle is called a sarcomere. And so you can see that on the next slide. And these sarcomeres are basically made up of protein. So protein is very important for your muscles. The protein that is thick is called myosin, and the one that's thin is called actin. And these two working together form these functional units called the sarcomeres. And they are alternated between the two with these dark lines called Z lines that separate the two of them. Now, these Z lines are what gives muscles its striped appearance, or its striated appearance. It makes it look like they are striped. But when these two proteins contract and they get closer together, it creates some cross bridges, and it pulls one after the other closer to itself until the muscle is contracted. And as I said, that's more of just a very quick summary. What's more important to me is that you know that sarcomeres are the functional unit of the muscle, and that they're made up of the two different proteins, myosin and actin. In order for this contraction to occur, we do need energy for our muscles. That energy comes in the form of ATP. And in addition, for our muscles to contract, in addition to that energy, we also need some calcium. So calcium is important not only for our bones and strong bones, it's also important for our muscles to contract. Now, you'll notice this as we go along through the different chapters. The slides will sometimes have a lot more detail than I make you know, and that's okay. You're more than welcome to look at that, like for this slide where it talks about sarcoplasmic reticulum and stuff like that. But for right now, I'm not going to make you know that. We are going to skip down to the slide that says muscular fuel. We said that muscles need energy, and it comes in form of ATP, but there is some other fuel that the muscles need in order to function. They need nutrients, they need oxygen, and things like that. And our body stores this substance called glycogen in our muscles, so that if we need extra energy, that it can convert this glycogen substance into glucose that we can use for energy then if we need. The muscles with these high demands of fat, high demands of energy, in other words, the muscles that you move a lot, your legs, things like that, they will have more of this stuff because they need more. And releasing this energy causes heat production. So remember I said before that muscles help with heat production and our temperature. And this is why when you exercise, as your body burns this glycogen and releases it, and the energy is being released and things like that, your muscles get warm and things. Now, the muscles that have these higher demands also need more oxygen. They need more blood supply and things like that, so that when you look at them, the muscles themselves will have a darker appearance. Think about a chicken. When you eat chicken, you have white meat and dark meat. The dark meat, by the way, some students don't know, when you're eating meat, you're actually eating their muscle. So that's why I'm using this as an example. So you have the white meat and you have the dark meat in a chicken. The white meat is in like the chicken breast, things like that, where they don't move them a lot, whereas the chicken legs and the chicken wings have darker meat, because those are things that are moved more frequently, and they have a higher demand of oxygen, they have a higher demand of energy, and so they have that darker appearance. And we are the same way, not that we have white and dark meat, but our muscles will be darker, that we use more. Now, we've talked about how smooth muscle is found in the different parts of our body. It's found everywhere. It's found in our blood vessels. That's how it interacts with the circulatory system. It's found in our bronchial airways. It's how it interacts with the respiratory system. It's found in our intestines. It's how it interacts with the digestive system. And that's just a few of the examples that of how muscles interact with our other systems. As we said, it interacts in the circulatory system in the form of blood vessels. When the muscles in the blood vessel, it's in the middle layer specifically of the blood vessels, contract, it makes the blood vessels smaller, or what we call vasoconstriction, which I accidentally did the second one first, so it's the bottom one there. Vasoconstriction, the inside of the blood vessel gets smaller because of the muscles contracting. And so what happens as a result of that is our blood pressure will increase because there's a smaller space there. The opposite is also true. When that muscle relaxes, it opens up that blood vessel and allows more blood to be able to get through. So our blood pressure will decrease. And when that happens, it's called vasodilation. So imagine yourself like you're on a 2-lane highway and it's jam-packed with traffic. Okay, so that's a lot of pressure. When all of a sudden that 2 lanes of traffic opens up to 4 lanes, that pressure is released and you can get more through. So the pressure has decreased. That was like when our blood vessels have vasodilation, and it kind of opens up, relaxes. You can get more things through there, so our blood pressure decreases. Now imagine the opposite, where you have a 4-lane traffic. 4 lanes of traffic, and all of a sudden you're trying to get down into 2. Now you're having this increase in pressure because everybody's trying to get down into 2. So that's kind of like vasoconstriction, when our blood vessels decrease in size and you can't get as much through there. It causes more pressure, more force in order to make that happen. Smooth muscles are also in, as I said, the respiratory tract. An example of this would be when somebody's having an asthma attack. These muscles are in the lines of our bronchi, which are the tubes in our lungs. And when those muscles contract, what happens is air gets stuck. And then we can't get the air in and out of the lungs. And so it causes that wheezing sound because of that constriction happening and that blocking of the airway. Another example of how smooth muscle plays a role in another system is with the digestive system. You have these special muscles along the digestive system that are called sphincters, and they're donut-shaped muscles that will open and shut and allow things through. So, for instance, at the end of the esophagus, there's one called the lower esophageal sphincter, or the LES, and it opens to allow food into your stomach. Then at the end of your stomach, you have another one called the Pyloric Sphincter that when it opens up, it allows food down into your intestine. And then, of course, there's another one that at the end of the intestine that when you need to get rid of your waste product, will open up and you can go to the bathroom. So these muscles, as you can see, are very important in order with the digestive system to allow food through and that kind of thing. Now, smooth muscle is a little different than skeletal muscle for a few reasons. So first of all, it does not contract as fast as skeletal muscles. It doesn't need to. In fact, skeletal muscle is 50 times faster at contraction than smooth muscle. Another difference between the smooth muscle from our skeletal muscles is the amount of blood supply. Again, there is not as much blood supply to the smooth muscle. So because of that, when smooth muscle is damaged, it will take longer to repair because the blood supply isn't as much. You can't get as much nutrients there to do the repair and so forth. So it does take a little bit longer in order for that to happen. Now that is all that I have for today. If you have any questions, shoot me an email and I'll try to get to it. Otherwise, we'll see you the next day of class.